Hello everyone and welcome to today's video on Docker interview questions at Simplilearn. In the spirit of preparing you for all the important job interview, today we are going to discuss a collection of Docker interview questions and answers for experienced, intermediate and primary levels. So guys, watch this video till the end if you want to crack Docker interviews.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
Now before we move on, there is just quick info for you guys. Simplilearn has got professional certificate program in cloud computing DevOps in partnership with ENICT and IIT Guwahati. In this, you're going to learn about Azure, AWS, DevOps, cloud infrastructure, and many more. You'll also gain hands-on experience through real-world projects in our premium sandbox cloud labs. So hurry up now and join the course link. The course link is mentioned in the description box. So guys, let's start with Docker interview questions and answers. So guys, let's start with our first question. That is, what is Docker? So guys, Docker is a containerization platform that allows developers to package applications and their dependencies into standardized units called as containers. Very basic question, and I hope so you would be aware of this one. Now let's move on to our second question. That is, how does Docker differs from virtual machines? Kind of tricky, but still you should have an idea of this. And the answer to the same question is, like, what happens unlike virtual machines, which require a hypervisor to run multiple operating systems into a single physical machine, the Docker containers shares the host of its operating system kernel and only contain the application and its dependencies. And that's how it differs from virtual machine. I hope so you would have got an idea regarding the same. Now let us move to our third question. The third question is, explain the difference between Docker image and Docker container. So guys, very basic question, and the answer to the same is, a Docker image is a template for creating Docker containers. It's a read-only template with instructions for creating Docker container. Docker container is a runnable instance of Docker image. So guys, our next question is, how do you create a Docker image? So guys, Docker images are typically created using a Dockerfile, which contains a set of instructions for building the image. The Docker build command is then used to build the image from Dockerfile. So in this way, you create a Docker image. So we'll move to the next question, which is related to the next one. And that is, what is a Dockerfile? So guys, a Dockerfile is a text file that contains instructions for building a Docker image. It includes commands such as from, run, copy, expose, and cmd. I hope so you would have got an idea regarding the same. Now let us move on to the next question. That is, explain the Docker run command and what it is. So guys, if we talk about the Docker run command, it is basically used to create and start a Docker container based on the Docker image. It can also be used to specify runtime options such as environment variables, network settings, and volume mounts. I hope so you would have got an idea regarding it. Now let us move to the next question. That is, what is Docker Hub? So guys, if we talk about Docker Hub is a cloud-based registry service that basically allows users to store and share Docker images. It provides public and private repositories for storing images as well as an integration with other services such as GitHub and Bitbucket. Very basic question. Now let us move on to the next question. That is, how do you publish a Docker image from Docker Hub? So guys, if we talk about it, to publish a Docker image to a Docker Hub, you first need to tag that image with your Docker Hub username and the repository name using the Docker tag command. It's very important, and remember this. And then you have to push the image to the Docker Hub using the Docker push command. So it was pretty simple. Now let us move on to the next question. That is, what are Docker volumes? So guys, if we talk about what are Docker volumes, so Docker volumes are a way to persist data generated and used by Docker containers. They basically allow data to be stored outside the containers writable layer, making it possible to share the data between containers and persist data even if the container is stopped or deleted. Very simple. These are some of the basic concepts that you will find on Docker documentation. So whenever you are preparing for your interview, I'll advise you to go thoroughly to the official documentation with Docker. It really helps. Most of the questions, like scenario-based questions, coding-based questions, are generally asked from there. Now let us move to the next question. It's a pretty interesting one. So it is basically asked from the architecture, and the question is, what is Docker daemon? So guys, Docker daemon, often referred to as Docker, is a background service that manages Docker objects such as images, containers, networks, and volumes. It runs on the host operating systems and handles requests from Docker Engine CLI or the other Docker client via Docker API. That is, so in this command, can you explain the significance of I flag, T flag, and docker run it ubuntu/bin/bash? So this is our command, and the interviewer is asking you to explain the significance of I and T flag. Okay, so basically the I flag stands for interactive. So whenever you use these flags, it keeps the standard input open even if not attached, essentially. It allows you to interact with the containers process, enables you to provide input to the commands running inside the container. And with respect to the T flag, if we talk about, then T stands for sudo TTY. T flag stands for sudo TTY. It basically allocates a sudo terminal for the container, allowing you to see the command prompt and providing a more shell-like interface for interaction. So without a T flag, you basically wouldn't get a nicely formatted terminal prompt, and your interaction with the container might also not feel as natural. So this is the significance of I flag and T flag. Now let us move on to the next question. What is the difference between add and copy in a Dockerfile? Very basic question. So guys, if we talk about add and copy, they basically both are used to copy files into the Docker image, but add additional functionality. Okay, so what does add do? It can basically copy files from remote URLs, decompress the files, and automatically set the file permissions. Very easy. Now let us move on to the next question. That is, what is the difference between CMD and entry point in a Dockerfile? So guys, if we talk about CMD, CMD specifies the default command to run when a container is started, while entry point specifies the command to run when the container is started and also additional arguments to be passed to the commands. So this was all about CMD and entry point. So guys, our next question is, what is Docker Compose? So guys, Docker Compose is basically a tool for defining and running multi-container Docker applications. It allows basically developers to use the YAML file to define the services and also networks and volumes. So that's a very basic definition of Docker Compose. So let us move to our next question. That is, so when a container exists, is it possible for you to lose the data? Like, very basic question. But the answer to the same is no, it's not possible to lose any data as long as the container exists. Like if you delete, then all the data will be lost. So that's the overall scenario for this question. It's a very kind of a tricky question, so just remember it. Now let us move to the next question. So next question is, what is the difference between logging and daemon logging? So a very frequently asked question, guys. So container logging and daemon logging refer to the different aspects of logging within the Docker ecosystem. If I talk about the container logging refers to the logging performed by applications running inside Docker containers. Whereas each container has its own isolated environment and it can generate its own logs just like any other applications. Whereas container logging captures the output, which is SDE out, standard output, and std dir of the process running inside the container. By default, this output is captured by Docker and can be accessed using commands like docker logs. So this was related to container logging. Now if we talk about daemon logging, guys. So guys, daemon logging refers to the login performed by Docker daemon itself. The Docker daemon is responsible for managing containers, images, networks, and volumes on the host system. Daemon login captures the events related to Docker's operations, such as container creation, container start-stop, image pull-push, network creation, and so on and so forth. So that's what's the basic difference between container logging and daemon logging. Now let us move to the next question. Does Docker provide support for IPv6? Very interesting question, guys. So if you are aware with the documentation, you will definitely answer this question. Yes, Docker does have some support for IPv6, but as per as my knowledge, it has become quite comprehensive and it's maturing as its support for IPv4. So that's what in the process right now. Let us move to the next question, and this is related to scaling. So the question is, how do you scale Docker horizontally? So guys, horizontally scaling in Docker involves running multiple instances of a service across multiple Docker containers to distribute the workload and improve performance, availability, and fault tolerance. And here's you can basically scale it. So first one is using Docker Swarm and Kubernetes. So what happens using Docker Swarm and Kubernetes? It happens a process of container orchestration. So these platforms provide a built-in support for horizontal scaling. They allow you to define desired replica counts for the services. And also the orchestration platform manages the deployment and scaling of the containers automatically, like what Kubernetes does in this scenario. So this is one way. There can be multiple ways. So have an open eye regarding this question. It can be asked in the interview. So guys, our next question is, how does CMD and entry point differs in a Dockerfile? So guys, it's a very interesting question and kind of frequently asked. So guys, use entry point instructions when building an executable Docker image using commands that always need to be executed. And you are going to use CMD instructions when you need an additional set of arguments that can act as a default instructions until there is explicit command line usage when Docker containers run. So that's what the basic difference between entry point and CMD is. Now let us move to the next question. That is, what is the purpose of volumes in Docker? Very theoretical question. So guys, in Docker, volumes provide a way to persist and share data between containers and the Docker host. They have several purposes. Like if I talk about first is a persistent data storage, then sharing data between the containers, performing optimization, performance optimization, integration with external storage systems, and many more. So this is the purpose of volumes in Docker. Now let us move to the next question. That is, what is the difference between Docker restart policies, no, on failure, and always? Very interesting question. So guys, if I talk about no means no automatic restart. Containers remain stopped after exit. Like if I talk about on failure, here automatically restarts a container if it exists with a non-zero exit status, like there will be a specified number of attempts. And in the case of always, it automatically restarts a container regardless of the exit status. So that's what the difference between all of these policies are. No, on failure, and always. Please take a note of this question. This is kind of very important. Now let us move to the next question. That is, what is the difference between Docker container and Kubernetes pod? So guys, Docker container is a lightweight, standalone and executable package that contains everything needed to run a piece of software, including code, runtime system, tools and libraries. It runs a single Docker host in a managed using Docker engine. If I talk about Kubernetes pods, it is a higher level abstraction that can contain one or more Docker containers along with shared storage, network resources, and configuration settings. It represents the smallest deployable unit in the Kubernetes, and it also provides an environment for running containers. So that's what the difference between the Docker container and Kubernetes pod is. Now let us move to the next question. That is, how do you secure Docker containers? Very interesting question and kind of a practical question. So guys, securing a Docker containers involves several steps. So it's a combination of best practices and security measures to protect the containerized applications and the underlying infrastructure. Here are some of the key strategies. First, use the official images. Utilize official Docker images from trusted sources, as they are regularly updated and maintained within the security patches. The next one is container image scanning. Employ container image scanning tools to identify vulnerabilities and malware in Docker image before deployment. Third one, you can reduce attack surface. Minimize the attack surface by removing unnecessary components, limiting privileges, and using minimal base images. Next one is container isolation. You're going to utilize container isolation mechanisms like namespaces, cgroups to restrict container access to the host system. You can also use secure configuration like configure Docker daemon and containers with the best security practices such as using least privilege, disabling unnecessary features, and also enabling security options like SecOmp and AppArmor/SELinux. So these were some of the ways in which you can secure Docker containers. Now let us move to the next one. That is, can you tell me some of the best practices for using Docker in the production environment? So this is one of the practical questions that has been asked most frequently. So guys, the answer for this question is using Docker in a production environment requires careful planning and adherence to the best practices to ensure reliability, scalability, and security. The first practice would be use official images. Utilize official Docker images from trusted sources as they are regularly updated and maintained with security patches. Next one is optimize container images. Minimize image size by removing unnecessary dependencies using multi-stage builds, optimize layer caching to improve deployment speed and reduce resource consumption. Third one is implement container orchestration. Use container orchestration platforms like Kubernetes or Dockerfile to manage containerized applications, automate deployments, and achieve high availability and scalability. Fourth one, you can automate builds and deployments. Implement CI/CD pipelines to automate the build, testing, and deployment of Docker images, ensuring consistency and reliability in production environment. And finally, you can monitor containerized applications. So these were some of the best practices that you can follow while using Docker in a production environment. Now let us move to the next question. That is, how do you automate deployments of Docker containers? So guys, automating the deployment of Docker container involves using CI/CD, means continuous integration, and continuous deployment pipelines to streamline the process of building, testing, and deploying containerized applications. So first one is you can use version control. Store the application code and Docker configuration in version control systems like Git. Have a CI/CD pipeline setup. Set up a CI/CD pipeline using platforms like Jenkins, GitLab, GitHub Actions. Configure the pipelines to trigger on code commits or pull requests to the version control repository. Third one is build Docker images. Use Dockerfiles to define the container images for your application. Configure the CI/CD pipelines to build Docker images automatically whenever changes are pushed to the repository. Use tools like Docker, BuildKit, or Canico for building Docker images in a CI/CD environment. So in this way, you can automate the deployment of Docker containers. Now let us move to the next question. That is, how do you perform rolling updates in Dockerfile? So guys, performing rolling updates in Dockerfile involves updating services in a Swarm cluster without causing downtime or service disruption. The first one is you have to update service definition. Modify the service definition to specify the updated Docker image version or any other configuration changes which you are going through. You can update the service definition using the Docker service update command or by modifying the Docker compose file used to deploy the service. Second one is rolling update strategy. Specify the rolling update strategy to control how Swarm performs and the update. The rolling update strategy defines parameters such as number of parallel tasks and the delay between the updates. Common rolling update strategies include parallelism, delay, and failure action. For example, guys, you can specify a rolling update strategy within parallelism of 2 and delay of 10 seconds using the update parallelism and update delay flags. Very easy. So this was all about how you can perform rolling updates. Now let us move to the next question. So guys, our next question is, what is Docker Content Trust? So guys, Docker Content Trust is a security feature of Docker that provides cryptographic verification of image integrity and authenticity. It ensures that only verified and signed Docker images are pulled and run on Docker host. So guys, let's move to the next question. That is, how do you configure automatic container restarts in Docker? So guys, answer to the same is, to configure automatic container, it starts in Docker, use the double start flag when running the container. Specifying the desired restart policy. Your option can include no for automatic starts, on failure to restart container, and that exit with a non-zero status. And you can also use always to restart the containers regardless of the exit status. For example, there is a command like docker run // restart equals to always and your container name, which can be my container. So in this command, it sets a container to automatically and it restarts always. So this was the answer to this question. Now let us move on to the next question. That is, how do you configure custom logging driver in Docker? Very, very good question. So guys, to configure a custom logging driver in Docker, you can follow these steps. First one is choose a logging driver. Select the custom logging driver compatible with Docker, like you can use Splunk and syslog. Next one is update Docker daemon configuration. Edit or create the Docker daemon configuration file. Then add a log driver key with the value set to the name of the custom logging driver. You can optionally configure the additional logging driver options under the log ops key. So in this way you can do it. Now let us move on to the next question. That is, how do you manage secrets in Dockerized application? So guys, to manage secrets in Dockerized applications, use Docker built-in secret management or external tools like HashiCorp Vault. So in this way, you can basically manage secrets in Dockerized applications. These were some of the theoretical questions that I've asked you guys. Mostly were kind of basic. And now we'll move to the second part of the question. Now in this series, what we are going to see, mostly we are going to figure out some of the scenario and some of the file-based questions. So guys, as you can see, I am using VS Code as my text editor. So let us see what we have all over here. Okay. So guys, as you can see in this question, it says there is a certain code written all over here. This is basically a Dockerfile. So it says use the official Node.js image as a base image from Node 14. Then you are setting up your directory all over here. You are copying the JSON and you are installing the npm package. Then you are copying the rest of the application. You are exposing the port 3000. And in order to run the Node.js application, this command is written. Now some of the basic question I'm going to start with this Dockerfile. So your interviewer can ask you questions like explain each line of the Dockerfile and its purpose. So you can see I have added the comments all over here and it defines the purpose. So like from Node 14, this means that I'm using the official Node 14 version, this image. And similarly, all the other lines, I have added the code. Okay. Now let us move to the second question. What is the purpose of workdir/user/src/app? So basically, as you can see all over here, it is setting up the directory in this folder. Now, let us move to the third question, which says, why do we copy *JSON files separately from the rest of the application code? Now, this is a pretty interesting question. And your interviewer can ask you something like this based on your Dockerfile. So guys, the answer for this question is, we copy package *.json files separately to take advantage of the Docker layer's caching mechanism. So this basically ensures that all the dependencies are only reinstalled when the dependencies change rather than on every code change. So that's why we are copying package *.json files. So this is one of the interesting questions and it can be asked. So now it's a very basic question, run npm install. Why do we expose port 3000 in the Dockerfile? Now let us see this question. So guys, exposing 3000 informs Docker that a container listens on the port 3000, which allows Docker basically to map that port to the host machine when we are running the container. And finally, it says what is the significance of command node app.js. So as I've told you, it basically is a command to run the Node.js application. So these are some of the basic questions that can be asked with respect to your Dockerfile. So you can have a check on these one. Now let us move to the next question. Now you can get an assignment certain like this, that write a Dockerfile for a simple Python Flask application. And you have to ensure that Dockerfile installs Python, copies the application code into the container, installs dependencies using pip, and exposes the port for Flask application to run on, say, port 3000. So basically, you have just seen a template Dockerfile. Now, we want to write a Python Flask application. So guys, let me show you the answer for the same. So similarly, you're going to start. So from Python 3.9, this is your latest Python which you want to use. Next process would be setting up your directory. So work.dir/app. Then you need to copy the current directory, copy./app. Install the Flask and other dependencies. So you're going to install it using pip. So run pip install /no cache directory Flask. Okay, and then you are going to expose your port like to 5000 to allow this communication to the Flask app. And finally, you are going to run this application. It is very simple, just a template I have used earlier. And in this way, your interviewer can give you some hands-on task to code a Docker file. Now let us move to the next question. I hope so you would have got a brief idea regarding this. Now, similarly, it says, write a Docker file that builds a custom Nginx image with SSL support. Now, okay, let me do this. Now it says, ensure that Dockerfile copies custom Nginx configuration files and SSL certificates into the image and exposes ports 80 and 443. So what is this, guys? If I talk about this, basically, it is asking for you to build a custom Nginx image, okay, and it should have an SSL support. Now, it should copy the custom Nginx configuration files and also the SSL certificates into the image, and it has given the specified ports to expose. Now, how would you tackle this? So the answer to the same is very basic. Start from Nginx, the latest version. Now, you have to copy the Nginx configuration files. So say copy nginx.conf/etc nginx nginx.conf, okay? Then you would do copy default conf, etc. nginx confd and default conf. So basically, you are writing this code to copy the custom Nginx configuration files, okay? So these are the two-step process. The next was to copy the SSL certificates. So copy the SSL certificate in the same fashion. So there will be a key and certificate. Now you have to expose the port 80 and 443. So for the HTTP, this would be an HTTP traffic, and this would be for HTTPS traffic. So this is how you are going to use it. It's a little bit tricky and complicated, but it's a template for you. Like if you are getting certain question regarding to use an Nginx or to expose two ports, you can use this template. It works perfectly well. Now let us move to the next question. That is implementing a multi-stage Docker build for Java application. So guys, it says you have to write a Docker file that compiles the Java application using Maven in the first stage and then copies the compiled jar file into a lightweight runtime image in the second stage. So this is a two-stage process. And so let's start with the first one. Let's figure out what is there in stage one. So it says that in stage one, you have to write a Docker file, okay, where it copies the compiled jar file into the lightweight image. This is in the second. And in the first one, it compiles a Java application using the Maven. Okay, very basic. So let me show you the template for this one. So there's a comment for stage one. So you have to use Maven. So I have selected from Maven 3. This is a current version. And for OpenJDK 11 AS Builder. So I'm building a Java application using the Maven. I'm setting up the directory all over here. Then I'm copying the Maven project descriptor file. So that will be a pom.xml file involved here. You're going to copy the source code finally, and you're going to build the Java application. So there is an nvn command for the same, run nvn package. So this is your stage one process. It's very important for you to see this. It's also kind of a little bit tempting question. Now, in the second stage, you have to build the Java application with Maven run nvn package. So here you have to create a lightweight runtime image. So I have used from OpenJDK 11 JRE Slim. Set up the working directory, copy //from builder /app target myapplications.jar. So you have to copy the jar files. Then you have to expose the given port. So 8080 is a port for the server. And finally run it, the cmd java jar and myapplication.jar file. So this is how we approach to a problem in a multi-stage process that are told to write in a Docker file. So as you practice more and more questions like this, guys, I am definitely sure that it will boost your confidence to tackle questions like these. Now, let us move to the next question, which are scenario-based questions. So guys, first scenario-based question is like, suppose there is a Docker container which is unable to communicate with another container on the same Docker network. But how would you diagnose and troubleshoot network connectivity issues between the containers? It's a very practical question, and there is a high probability that your interviewer can ask this. So guys, to troubleshoot and resolve a Docker container, start a failure related to containers entry point script, you should follow these steps. First one is check the container logs. Okay, so start checking by container logs to see if there are any error messages or any exceptions related to the entry point script. You can use commands such as docker logs commands to view the containers logs. Next one is inspect the container configuration. Use docker inspect command to inspect the container's configuration and verify the entry point script specified in the Dockerfile. Third one is you can verify the entry point script permissions. Here you have to ensure that the entry point script has the correct permissions to set the executable within the container. Fourth one is to test the entry point script locally. You have to copy the entry point script from the container to your local machine and test it to see if it executes successfully outside the container environment. So this basically can help to isolate any issues with the script itself. So these are some of the process in which you can follow up to check if one of the container is not able to communicate with the other on the same network. Now let us move to the next question. That is, it says you are trying to build a Docker image for a Python application using a Dockerfile. Okay. However, the build process fails with an error indicating that a required Python package cannot be installed. How would you modify the Dockerfile to ensure the package is installed successfully? Wow, what a great question. Let us try to tackle this question. So guys, any issues related to diagnosing and troubleshooting network connectivity involves like between Docker containers. There can be a varying steps that one can go, but I'll approach this problem something like this. First of all, I would check the Docker network configuration. Okay, I'll start by verifying both of the containers. Are they connected to the same Docker network? Okay, and for this, I can use Docker network inspect command. Next one is I can verify the containers IP addresses. Check for the IP addresses assigned to the containers within the Docker network. For this purpose also, you can use a Docker inspect command. Third one is you can test the connectivity using ping. You can use a ping command to test the connectivity between the containers by pinging one container from other using its IP address. Next one is check the firewall rules. Ensure that there are no firewall rules blocking the traffic between two containers within the network. Then inspect the containers processes and ports. Check if the required services or processes are running inside the containers and listening on the correct ports. And finally, check for Docker logs for errors. Inspect the Docker container logs for any errors or warning related to network connectivity. For this purpose, you can use Docker logs command. So in this way, you can troubleshoot your program. So guys, here is the next question. And it's a pretty interesting one. And it says something like this. Suppose you have a Docker Compose file that defines multiple services for a microservice architecture. Okay? And then each service runs a different application component such as front-end, back-end, and a database. However, you notice that the front-end service intermittently loses connectivity to the back-end service. How would you troubleshoot and fix this issue? This is a very practical problem, and when you are deploying your application on Docker, you might face these issues. So your interviewer can ask you this type of question also. So how would you approach this question? So the answer to the same is like, so guys, whenever you have a problem related to troubleshooting the intermittent connectivity issues between services in a Docker Compose setup, so it can be a little bit of complex issue. But if you go through a systematic approach, like which I'm going to tell you, you might find an easy way to resolve this issue. So first of all, what I would like you to do is you have to check your Docker Compose configuration, where you have to ensure that your Docker Compose configuration in the Docker Compose.yml file is correctly defined the network settings for the services. You have to pay attention to the services names like the ports, network mode, and many more. Then you have to inspect the logs. Check for the logs of both front-end and back-end services for any error messages or warnings that might indicate the network-related issues. For this purpose, use Docker Compose logs to view logs for specific services. Third one is you have to check for the container health check. You have to verify that the health of the container is running in the front-end and the back-end services. Use Docker PS to list all the running containers and check their status. If any container is restarting frequently or has exited unexpectedly, investigate the cause. Fourth one is network connectivity. Check if the front-end service can be resolved the host name of the backend service. You can do this by executing a command within the front-end container, or ping resolve the host name of the backend service. For example, you can type this command like docker compose, then exec. Then suppose your front end is a given directory, so write front end and try to look up nslookup backend. So you can type this command all over here and it's going to check a given issue. So guys, you can type this command to troubleshoot this issue. Next thing is, you can also try for service dependencies. So you have to also ensure that the front-end service waits for the back-end service to be fully initialized before attempting to connect. Sometimes intermittent connectivity issues occur because of the front-end service starts before the back-end service. So you can add a delay or retry mechanism in the front-end service initialization script. Now, finally, you have to check also the Docker networking, where you have to review the Docker's networking modes like bridge, host, overlay, etc. And you have to ensure that the chosen mode is appropriate for your setup. Please make it sure that this is a very important point. And also you have to look for Docker built-in networking features like user-defined networks for better isolation and control over communication between the services. So this is one thing. Now, let us move to the next part. That is the next question. So it says you are attempting to optimize a Docker build process for large Java application. But however, you are encountering a challenge where the final image size is larger than expected. So how would you prefer to refactor the Dockerfile to reduce the size of the final Docker image without sacrificing the functionality? Very practical question, guys. So how would you approach this question? Take a time as you have read the documentation or did some projects. So you can pause this video for a while and try to think of an approach which can resolve this issue. So I would approach this question something like this. So in order to reduce the final Docker image size for the Java application using multi-stage builds, first I would check the base image selection. You have to choose a minimal base image for the final stage, such as an Alpine Linux or distroless Java, to reduce the size of the image. Next one, you have to minimize the dependencies in the final image, excluding unnecessary packages and libraries. Utilize tools like Maven or Gradle to exclude dependencies which are not required for the runtime. Third one is optimize copy operations. You have to optimize copy operations by copying only necessary files and directories from the build stage to the final stage. Utilize Docker ignore to exclude all the irrelevant files and directories from the build context. Next one is layer optimization. Guys, combine multiple run commands into single run instruction to reduce the number of layers in the final image. You have to utilize Docker build cache efficiently by ordering commands from the least frequently changed to the most frequently changed. And finally, you have to look for static content compression. Compress static content like HTML, CSS, JavaScript file using techniques like Brotli or gzip before copying them into the final image. So this is how I would try to do it. And one more point I can add it, that I can also review the container configuration optimization. I would review and optimize JVM and application server configurations to reduce the memory footprint and also improve the performance. I'll adjust JVM heap size, garbage collection settings, and thread pool configurations based on application requirements. So in this way, if you approach this question, I think so your interviewer will be very, very impressed. Now, let's move to the next question, which is the question, when you are deploying a Dockerized application to a Kubernetes clusters using Helm charts, however, when you attempt to deploy the application, you would encounter an error indicating that the container is unable to mount a volume. And how would you debug and resolve this issue within the Helm charts and Kubernetes deployment configuration? Quite an interesting question. Now, let us see the approach to solve this problem. So guys, whenever you want to debug and resolve the issue of a container which is unable to mount a volume in a Kubernetes cluster deployed using Helm charts, you can follow these steps. First part, inspect the Helm chart configuration. Review the Helm chart templates and value files to ensure that the volume configuration is correctly defined. Then you have to verify that the volume type name, mount path, and other properties are accurately specified in the Helm chart. Check for Kubernetes resources. Use kubectl get pods, kubectl describe pods, or kubectl logs command to inspect the status and logs of the pods affected by the volume mounting issues. So guys, you can use these codes. Okay, these are the certain commands. So, okay, this is one, or same, and here you could just type describe pods, or you can go for kubectl logs. Okay, and you can make the k as small. Okay. So this makes one of the answers for this question. Next thing is what you can do, guys. You can verify the volume configuration. Check for persistent volume and persistent volume claim, PV and PVC. Use these resources and check that they are correctly configured and available in the Kubernetes cluster. Ensure that the PV and the PVC have matching names, storage class, access mode, and other properties required for volume provisioning and mounting. Next one is troubleshooting the volume provisioning. If dynamic volume provisioning is used, you have to verify that the storage class is specified in the PVC available and capable for provisioning the volumes. You have to check the status of the storage provider, like the cloud storage service, to ensure that it is operational and accessible from the Kubernetes cluster. Then fifth one is permission and access. You have to ensure that the Kubernetes service account used by the pod has the necessary permissions to access and mount the volume. If using secrets or config maps as volumes, you can verify that they are correctly configured and accessible by the pods. So these were some of the points which you can mention, and in this way, you will completely answer this question. Now, let us move to the next question. That is, suppose you have a complex microservice architecture, okay, which is deployed on a Docker Swarm cluster. Now, one of the microservices which handles critical financial transactions experiences intermittent performance issues, causing delays and potential financial losses. You need to diagnose and resolve the issue promptly to ensure the stability and reliability of the application. So, how would you approach this question, guys? So guys, diagnosing and resolving intermittent performance issues in a critical microservice handling financial transactions on Docker Swarm cluster requires kind of bit systematic approach. So first of all, I would like you to look for monitoring and logging. You have to utilize Docker Swarm's built-in monitoring capabilities or the third-party monitoring tools to gather metrics on CPU usage, memory utilization, network traffic, and container health. Analyze container logs for any error messages, warnings, or patterns indicating performance bottlenecks. Check resource utilization metrics to identify if there are any spikes or anomalies in CPU or memory usage that coincides with the performance issues. Ensure that the microservice has sufficient CPU, memory, and network bandwidth allocated to handle peak loads. Third one is network latency. Investigate network latency between the microservice and other components in the Docker Swarm clusters, including databases, external services, and other microservices. Check out for network congestions, packet loss, or communication issues that could impact performance. Fourth one is you have to look for database performance. Examine the performance of database assessed by the microservice. Monitor query execution times, database logs, and indexes to identify potential database-related bottlenecks. You can also go for optimizing the database queries, indexes, and configuration settings to improve query performance and reduce latency. Now, next thing what you can do is you can go for scaling and load testing. Consider scaling the microservice horizontally by adding more replicas to distribute the workload across multiple containers. You can perform load testing to simulate real-world transaction volumes and identify performance limits and scalability issues. Next thing, you can go for continuous monitoring and alerting. Implement continuous monitoring and alerting systems to proactively detect performance issues and notify stakeholders in real time. Set up alerts based on predefined thresholds for CPU, memory, latency matrix to trigger investigation and remedial actions. Now, what you have to do next is do incremental changes and testing. Make incremental changes to the microservice configurations, code base, or infrastructure settings based on diagnostic findings. Test changes in staging environment before applying them to the production to ensure they do not introduce regression or new issues. So guys, by following these steps, leveraging monitoring, diagnostic, optimization techniques, you can diagnose and resolve intermittent performance issues in a critical microservice, ensuring stability and reliability of the financial transactions which you have applied running on the Dockerfile cluster. So guys, I hope so. You would have got a brief idea now how your interviewer can ask you questions regarding Docker. So that was it for today's session. I hope so you have enjoyed our today's video on Docker interview questions. Thank you for watching this video.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.